And now in this lecture we'll answer two questions. In the first question we find out the height of this right triangle ABC, the height edge of this right triangle ABC. And in the second question we find out the area of this square ABCD, and we have also to find out the length of this tangent QP. So we start with the first question. In the drawing we have the right triangle ABC. This is angle ABC, this is the right angle. Side BC of this triangle ABC equals to 40 units in its length. Inside this triangle ABC we have a circle that is inscribed by this triangle ABC. The radius of this circle is 4, and our task is to find out the length of side AB. That is actually the height of this triangle ABC. So first of all, we will define the relevant points for this question with letters. And again, we define the relevant point of this question with letters. We define the center of this circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point D. We define the point of tendency of tangent BC with this circle. This point is point E. And finally, we define the point of tendency of tangent AC with this circle. This point is point F. In the next step, we will join points O and D together by a straight line. Point O is the center of this circle. Point E is the point of the circle itself. Therefore, OE is the radius of this circle. That is equals to 4. The radius OE is equals to 4. The radius OE is drawn to point E. This is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees in its size. And this angle also equals to 90 degrees in its size according to rule 1. Likewise, we will join points O and D together by a straight line. And again, we will join points O and D together by a straight line. OD is of course the radius of this circle. This is equals to 4. The radius OD is equals to 4. The radius OD is drawn to point D. That is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to the sum rule, rule 1. So inside the small quadrilateral DOEB, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this 4-piece angle, in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4-piece angle must be equal to 90 degrees in its size. So inside the small quadrilateral DOEB, we have 4 angles, and therefore we can relate to quadrilateral DOEB is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle DOEB, side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the sum rule, in the same small rectangle DOEB, side OE must be equal to the opposite side DB, but OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So in total, we should found out that quadrilateral DOEB is not a rectangle, but a square, where because all of its sides are equal to each other. Each side equals to 4. What is the length of this BC 97970 EC? EC in total equals to BC minus BE. So it is known EC equals to BC minus BE. So EC equals to BC is 40, minus BE. BE is 4. So in total, EC equals to 40 minus 4, that is 36. So EC equals to 36 units in its length. In the next step, we will implement rule 2 in our drawing. So I please click on rule 2. According to rule 2, the lengths of two tangents from a convex standpoint to a circle are equal. In the drawing, we have this circle. This is the convex standpoint point P. From this convex standpoint point P, we have two tangents to the circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Because in our drawing, we focus at this convex standpoint point C. From this convex standpoint point C, we have two tangents to the circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But CE equals to 36, therefore CF must be also equal to 36 units in its length. Likewise, we focus at this convex standpoint point A. From this convex standpoint point A, we have two tangents to the circle, tangent AD and tangent AF. And according to rule 2, they are equal to each other. That is to say, AD equals to AF. So if we define the length of side AD as X, then side AF must be also equal to X according to rule 2. So in the next step, we will implement the Padar's theorem on this big right triangle ABC. According to the Padar's theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. Here by PT is the relation for Padar's theorem. So in this right triangle ABC, according to the Padar's theorem, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. So it is now AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. AC in total equals to X plus 36, therefore AC squared is X plus 36 squared. And it is equal to AB squared. AB in total is X plus 4, therefore AB squared is X plus 4 squared. Plus BC squared. BC equals to 40, therefore BC squared is 40 squared, that is 1600. So in total, we actually found out that X plus 46 squared equals to X plus 4 squared plus 1600. Here we'll open the brackets on both sides of this equation and we get that X plus 36 squared equals to X squared plus 36 squared equals to 1296 plus 2 times X times 36, that is actually 72X. And it is equal to X plus 4 square. X plus 4 square equals to X square plus 4 square, that is 16, plus 2 times X times 4, that is 8X plus 1600. Here we have X square on both sides of this equation, so X square gets cancelled. After cancelled X square, inside of the equation we left only with 1296 plus 72X. And on the other side of the equation we have 16 plus 1600 is 1616 plus 8x. Here we will subtract 8x from this equation. So here at x will get cancelled, we have only 1616. While on the other side of the equation, we have 1296, and 72x minus 8x is 64x. So in total, we found out that 1296 plus 64x equals to 1616. Here we subtract 1296 from this equation. So here 1296 will get cancelled, and we're left only with 64x, while on the other side of the equation, 1616 minus 1296 equals to 320. So in total, we found out that 64x equals to 320. Here we divide this equation by 64. So 64x over 64 is x, equals to 320 over 64 is 5. So in total, we found out that x equals to 5 units in its length. Our task is to find out the height of this triangle ABC, the height h, is equals to AB. So AB in total equals to AD plus DB. Height h equals to AB, AB equals to AD plus DB. So AB equals to AD is x, plus dB is 4. So in total, AB equals to x plus 4, but x is 5, so AB equals to 5 plus 4, that is 9. So in total, we should found out that side AB of this side ABC equals to 9 units in its length. So we finished to answer the first question. The next step, I'll present you the second question of this lecture and answer the second question. In the second question, our task is to find out the area of this square ABCD, and we also have to find out the length of this tangent QP. So in the domain, we have a quarter circle and a semicircle. They are both located inside this square ABCD. QP is the tangent to this, to both the quarter circle and the semicircle at this point. So we define the point of tendency of tangent QP with the quarter circle and the semicircle. This point is point K. We know also that the radius of this semicircle equals to 17 units in its length, and the radius of this quarter circle equals to 36 units in its length. So in the first step, we will define, again our task is to find out the area of this square ABCD, and we have to find out also the length of this tangent PQ. So in the first step, we will define the relevant points to this question with letters. We will define the center of this semicircle, this point is point O. We will define this point as point L. We will define the length of line segment LB as X. We will define this point as point Z, and we define the length of the short line segment BZ as Y. Point D is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore, DL is the radius of this quarter circle. This equals to 36 units in its length according to what is given in the question. So DZ equals to 36. So our first task is to find out the area of this square ABCD. So what is the area of square ABCD? Actually, we know that the area of any square equals to the length of one side squared. So we choose side AB, it's one side of square ABCD. Therefore, the area of square ABCD must be equal to AB squared. AB in total equals to, here OL is the radius of the semicircle, is equals to 17. 17 plus 17 is 34, so it is AB in total equals to 34 plus x. AB in total equals to 34 plus x units in its length. Therefore, AB squared must be equal to 34 plus x squared. So, according to the first method of calculation, we actually found out that the area of this square ABCD is equal to 34 plus x squared. In the next step, we'll choose side BD as one side of square BCD. Therefore, the area of square BCD must be equal to BD squared. So according to the second method of calculation, the area of the same square ABCD is equal to BD squared. It's the length of one side square, so it is BD squared. BD in total equals to y plus 36, therefore BD squared is equal to y plus 36 squared. BD squared equals to y plus 36 squared. So in total, we found out that according to the second method of calculation, the area of the same square ABCD is equal to y plus 36 squared. So we have two different equations for the area of the same square ABCD. Equation 1 and equation 2. Therefore, we get equation 3 that says that the area of the square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. So according to equation 3, the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. So the area of square ABCD according to the first method of calculation equals to 34 plus x squared, and it must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to y plus 36 squared. So in total, we found out that according to equation 3, 34 plus x squared equals to y plus 36 squared. Here we take a root out of this equation. Here the root cancels the square, and we left only 34 plus x in this side of the equation. 34 plus x. While on the other side of equation 3, the root cancels the square, and we left only with y plus 36. So in total, we found out that 34 plus x equals to y plus 36. Here we subtract 34 from this equation, and we get that here 34 we can cancel, and left only if x on this side of the equation, while on the other side of the equation we have 36 minus 34 is 2, so in total, in the other side of the equation we left with y plus 2. So in total, we found out that x equals to y plus 2. X equals to y plus 2. We can implement rule 10 in our drawing. Why? Because we have an external between the semicircle and the quarter circle at point K. That is to say, the semicircle and the quarter circle touch each other externally at point K. Therefore, we can implement here rule 10. So I could click on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes through their touching point. So in the drawing we have those two circles that touch each other externally, this point, point P. The center of this circle is Z point O. The center of this circle is Z point M. The straight line that connects their centers together is of course the straight line OM. According to this rule, rule 10, the straight line OM must pass through their touching point, that is point P. The straight line OM must pass through point P, that is their touching point. OPM is one straight line. Again, OPM is one straight line. So if OPM is one straight line, it means that OM in total must be equal to OP plus PM. So we can actually implement rule 10 in our drawing. In our drawing, the semicircle and the quarter circle touch each other externally at point K. The center of this semicircle is 0 at point O. The center of this quarter circle is 0 at point D. The straight line that connects the centers together is of course the straight line OD. According to this rule 10, the straight line OD must pass through their touching point, that is point K. Again, the straight line OD must pass through point K, that is their touching point. OKD is one straight line. OKD is one straight line. So we join points OD together by straight line, and according to rule 10, the straight line OD must pass from point K, that is their touching point. So from the drawing, it is very easy to see that indeed the straight line OD passes from point K, that is the touching point, exactly according to rule 10. And according to rule 10, this, OD in total equals to OK plus KD. So OD equals to OK plus KD according to rule 10. So OD in total equals to OK. OK is the radius of this semicircle, that equals to 17 units in its length, plus KD. KD or DK is the radius of this quarter circle, that equals to 36. So in total we should know that OD equals to 17 plus 36, that is 53. OD equals to 53 units in its length, according to rule 10. So I did not, OD equals to 53 units in its length. ABCD is a square, therefore this is a right angle. So in the next step, we will implement the Padar's theorem on this right green triangle, triangle OBD. Again, we will implement the Padar's theorem on this green right triangle, triangle OBD. On this right triangle OBD, according to the Padar's theorem, we get that OD squared, that is the square of the hypotenuse, equals to ODB squared plus BO squared. So it is now, in the right triangle OBD, according to the Padar's theorem, the following equation is so. Here by PT is the equation for Padar's theorem. According to the Padar's theorem, this green right triangle OBD, OD square, that is the square of the hypotenuse, equals to BD square plus OB square. But again, according to the Padar's theorem, in this green right triangle OBD, OD square, that is the square of the hypotenuse, must be equal to BD square plus OB square. OD is 53, therefore OD square is 53 square. 53 square equals to 2,809. and it is equals to BD square. BD in total is 36 plus y, therefore BD square is 36 plus y square. Plus OB square. OB in total equals to x plus 17, therefore OB square is x plus 17 square. So in total we found out that 2809 equals to 36 plus y square plus x plus 17 square. We already found out that x equals to y plus 2. So we substitute x in this equation by y plus 2, and we get that 2809 equals to 36 plus y square plus x plus 17 square. X is y plus 2, therefore x plus 17 is y plus 2 plus 17. Y plus 2 plus 17 is y plus 19. Y plus 19 squared. So in total we found out that 2809 equals to 36 plus y square plus y plus 19 square. So 2809 equals to 36 plus y square. 36 plus y square equals to 36 squared, that is 361. Plus y square plus 2 times 36 times y, that is 72y. Actually, 36 square equals to 1296. So today we found out that 2809 equals to 1296 plus y square plus 72y. And it is equal to y plus 19 square. Y plus 19 square equals to y square plus 19 square, that is 361 plus 2 times y times 19 is 38y. So in total we found out that 2809 equals to, here we have y square plus y square is 2y square, and we have also 1296 plus 361, in total is equals to 1657. And finally we have 72y plus 38y equals to 110y. So in total we found out that 2809 equals to 2y square plus 1657 plus 110y. So here we subtract 2809 from this equation. So here 2809 we get cancelled and we left only with 0 here. And on the other side of the equation we have 2y square plus 110y, and 1657 minus 2809 equals to minus 1152. So in total we found out that 2y square plus 110y minus 1152 equals to 0. Here we divide this equation by 2, and we get that 2y square over y square is y square, and 2y square over 2 is y square, plus 110y over 2 is 55y, minus 1152 over 2 is minus 1600 minus 576. Minus 576 equals to 0 over 2 is 0. So in total we should find out that y squared plus 55y minus 576 equals to 0. So this is a quadratic equation. And the general formula of a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. This is general formula for a quadratic equation. A, b, and c are the coefficients of this quadratic equation. And x is the variable that we are looking for. And we find out the value of x according to the following general formula. X equals to minus b plus minus root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. The variable that we're looking for is y, so x equals to y. The coefficient a equals to 1. The coefficient b equals to 55. And finally, the coefficient c equals to minus 576. So here we have all the data that is needed in order to find out the value of y. We just have to put the data of our specific quadratic equation inside this general formula points, and this way we find out the value of the values of y, because y might have two solutions. So we do it now, we get that x equals to y, because y is the variable that we're looking for. Now, specific quadratic equation. So y equals to minus b. B is 55, therefore minus b is minus 55, plus minus the square root of b squared. B is 55, therefore 55 squared equals to 3025, minus 4 times a times c. So it is minus 4 times a is also minus 4 times 1 is minus 4 times c. C is minus 576, so minus 4 times minus 576 equals to 2304. So total inside the root we have 3025 plus 2304 divided by 2a. A is 1, so 2a, 2 times 1, that is 2. So in total we should find out that y equals to minus 55 plus minus, inside the root we have 3025 plus 2304. 3025 plus 2304 equals in total to 5329. So inside the root we have 5329 divided by 2. It again, in total we should find out that y equals to minus 55 plus minus the square root of 5329 over 2. So y equals to 55 plus minus the square root of 5,329 is 73 over 2. So here we have two solutions that are possible for y. We take into account only the positive solution for y, one because of the fact that y is the length of the short answer bz, therefore it must be a positive number. So the positive solution for y is as follows. Y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18. 18 over 2 is 9. So in total, if you found out that y equals to 9 units in its length, and we already found out that x equals to y plus 2. X equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So in total, we actually found out that x equals to 11 units in its length, and y equals to 9 units in its length. Our first task is to find out the area of this square ABCD. So what is the area of square ABCD? We only found out that the area of square ABCD equals to AB squared. The area of square ABCD is equal to AB squared. AB in total equals to 17 plus 17 is 34 plus x. If AB is 34 plus x, it means that AB squared must be equal to 34 plus x squared. But x is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared equals to 2025 square inches in size. Okay, again, in total, if you found out the area of square ABCD, that is the area that you're looking for this question. In total, it is equal to 2025 square inches in size. And again, in total, if you found out that the area of this square ABCD, that is the area that we are looking for in this question, is equal to 2025 square inches in its size. The first test, the second test is to find out the length of this tangent QP. So what is the length of tangent QP? We have to find out the length of this tangent QP. So first of all, we define this angle ODB as alpha. And we'll focus on this green right triangle OBD. On this green right triangle OBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. This is tangent PQ, that is tangent to the quarter circle at point K. The radius dk of the quarter circle, the radius dk is equal to 36, the radius dk is drawn to point K, that is the point of tendency of tangent PQ with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees in its size. And this angle also equals to 90 degrees inside according to rule 1. So inside the small green triangle QKD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in a triangle. Therefore this first angle must be equal to 90 degrees minus alpha. So in the next step we will do a construction, that is to say from this point B, we will do perpendicular on BD. Again from point B, we will do perpendicular on BD. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to our construction. When you find the touching point of the perpendicular from point B and BD, this point is point T. By doing this construction, we get the small quadrangle PTDC. Inside the small quadrangle PTDC, we have those two angles that are both right angles. Why? Because there are the two angles inside square ABCD. We know that the angles in all the angles in N square is equal to 90 degrees. Those two angles are right angles. Both right angles. And this is the right angle according to our construction. So in total, inside quadrangle PTDC, we have 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this surface again, total must be equal to 360 degrees, according to the rule that says that the sum of the angles in a quadrangle is equal to 360 degrees, and therefore this surface again must be equal to 90 degrees in its size. So inside the small quadrangle PTDC, we have 4 angles, and therefore quadrangle PTDC is a rectangle. What is the length of this side AB of this square ABCD? AB in total equals to 34 plus x. But x is 11, so AB in total equals to 34 plus 11, that is 45. Therefore CD must be also equal to 45 units in its length. Likewise, side BD of square ABCD must be also equal to 45 units in its length. Because of the fact that all the sides in N square are equal to each other in their lengths. So inside the right triangle QPT, we have this angle equals to alpha, this angle equals to 90 degrees, this angle equals to 90 degrees. This right triangle again, this right triangle PQT, this angle is right angle according to our construction. This angle equals to 90 degrees minus alpha, and therefore this missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Therefore this missing angle must be equal to alpha. In the next step, we will prove that the green right triangle OBD can go into this right triangle QPT according to angle side angle rule. So I do not. We have to prove that the green right triangle OBD can go to the right triangle QPT according to angle side angle rule. So once again, right triangle OBD can go into this right triangle QPT. First of all, those two angles are both equal to alpha, therefore they are equal to each other. So actually this is again BDO. the right triangle OBD is equals to this angle, this angle QPT, the right triangle QPT. And again, if you found out that angle BDO in the right triangle OBD equals to angle QPT, in the right triangle QPT, they are both equal to alpha, and therefore they are equal to each other. In addition, side BD of this right triangle OBD equals to side PT of this right triangle QPT. Before that, in rectangle PCDT, the opposite sides are equal to each other. That is to say, CD equals to the opposite side PT. But CD is 45, therefore PT must be also equal to 45 in its incidence line. Okay, again, side BD of this right triangle OBD equals to side PT of this right triangle QPT. So BD equals to PT. And again, side BD of the right triangle equals to side PT of the right triangle QPT. They are both equal to 45 degrees and to 45 units, and therefore they are equal to each other. Let's see, BD equals to 45 and PT also equals to 45. And finally, those two angles are both right angles, and therefore they are equal to each other. So actually this is again OBD on the right triangle OBD, and it is equals to this angle, this angle QTP on the right triangle PTQ. So repeat again, if you want on the angle OBD in the right triangle OBD equals to angle QTP in the right triangle QTP, they are both equal to 90 degrees, and therefore they are equal to each other. So in order, we should prove that the right triangle OBD congruent, this is the side of congruent to the right triangle QPT according to angle side angle rule. That is to say, we can prove that those two angles and the side that included between those two angles in this right triangle OBD are correspondingly equal to those two angles and the side that included between those two angles in this right triangle QPT. And therefore those two right triangles can go to each other according to angle side angle rule. Again, we have those two angles and the side is included between those two angles in this right triangle are correspondingly equal to those two angles. The side is included between those two angles in this right triangle QPT. And therefore those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that their corresponding sides must be also equal to each other and their lengths. The corresponding side of OD in the right triangle is side QP in triangle QPT. So OD equals to QP. OD equals to QP according to the rule that said that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore their corresponding sides, that is to say OD and PQ, must be also equal to each other and their lengths. Why OD is the corresponding side of QP? Because OD is the opponent of this right triangle OBD, therefore it must be equal to the opponent of this triangle QPT, that is actually QP. So QP is the corresponding side of OD. But we already found out that OD equals to 53. OD equals to 53. And for this equation, 53 equals to OD equals to QP, we will derive that QP must be also equal to 53 units in its length. And again, if you want to know that the length of tangent QP equals to 53 units, again, the length of tangent QP equals to 53 units, and the area of this square ABCD, that is the area that we're looking for in this question, is equal to 2025 square units in size. So finish to answer the second question, and the next step, I will start with the next step, that is to say, repeat on the solution of the first question, and then repeat on the solution of this second question. The first question, our task was to find out the height of this right line ABC, the height h. The height h is equal to AB. So in the drawing we have the right line ABC. Actually this circle is inscribed by the right line ABC. Angle ABC is the right angle. Side BC equals to 40 units in its length. The radius of this circle equals to 4 units in its length. Again, our task is to find out the length of side AB to the height of triangle ABC. So first of all, we define the relevant point to this question with letters. We define the center of this circle, this point is point O. We define the point of tendency of tangent AB with this circle, this point is point D. Likewise, we define the length of tangent BC. We define the point of tendency of tangent BC with this circle, this point is point D. And finally, we define the point of tendency of tangent AC with this circle, this point is point F. The next step is join points O and D together by straight line. Point O is the center of this circle, point E is the point of the circle itself, therefore O is the radius of this circle, that is equals to 4. The radius of O is equals to 4, the radius of O is drawn to point E, that is the point of tendency of tangent BC with this circle. And whenever your radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this circle equals to 90 degrees, and this circle also equals to 90 degrees according to rule 1. Likewise, you join points O and D together by straight line. O is the radius of the circle, that is equal to 4. The radius of D is equal to 4, the radius of D is drawn to point D, that is the point of tendency of tangent B with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this circle equals to 90 degrees, and this circle also equals to 90 degrees according to the sum rule of 1. So in total, inside the small quadrilateral DB, DO, EB, we have 1, 2, 3 addresses. The sum of 3 addresses is 270 degrees, so 270 degrees plus the side on this fourth missing, and total must equal to 360 degrees according to rule. The set that the sum of the addresses in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing must equal to 90 degrees inside. So inside the small quadrilateral DOEB, we have 4 addresses, and therefore we get quadrilateral DOEB is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle DOEB, side DO must be equal to the opposite side BE, but DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the sum rule, the sum of the DOEB, side OE must be equal to the opposite side DB, but OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So in total, if you all know that the small quadrilateral DOEB is not a rectangle, but a square, by virtue of the fact that all of its sides are equal to each other, each side equals to 4. What is the length of this missing line segment EC? EC equals to BC minus BE. EC equals to BC minus BE. So EC equals to BE, that is 40, minus BE, that is 4. So in total, EC equals to 40 minus 4, that is 36. EC equals to 36 units in its length. So here you can implement rule 2 in our drawing. So please click on rule 2. According to rule 2, the lengths of two tangents from common standpoint to a circle are equal. So in the drawing, we have a circle. This is the common sum point P. From this common sum point P, we have two tangents to this circle. Tangent BA and tangent BB. And according to all two, they are equal to each other. This is to say PA equals to PB. So we can actually implement all two in our drawing. We put in our drawing. From this common sum point C, we have two tangents to this circle. Tangent CE and tangent CF. And according to all two, they are equal to each other. That is to say CE equals to CF. But C equals to 36, therefore CF must be also equal to 36 units in step. Likewise, we focus on this common sum point A. From this common sum point A, we have two tangents to this circle, tangent AD and tangent AF. And according to all two, they are equal to each other. That is to say AD equals to AF. But if we define AD as X, then AF must also equal to X according to all two. The next step, we implemented the quadrat theorem on this big right triangle, triangle ABC. According to the quadrat theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in this right triangle ABC, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. Okay, again, in this right triangle ABC, according to the quadrat theorem, AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC in total equals to x plus 36, therefore AC squared is x plus 36 squared, and it is equal to AB squared. AB is x plus 4, AB is x plus 4, therefore AB squared is x plus 4 squared, plus BC squared. BC is 40, therefore BC squared is 40 squared, it is 1600. So in total, I should found out that x plus 36 squared equals to x plus 4 squared plus 1600. Here we open the brackets on both sides of this equation. And I should found out that x plus 36 squared equals to x squared plus 36 squared, that is 1296, plus 2 times x times 36, that is plus 72x. You understand the equation? We have x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, plus 1600. We have x squared on both sides of this equation, so x squared against cancelled. After cancelled x squared on this side of the equation, we have to leave 1296 plus 72x, while on the other side of the equation, we have 16 plus 1600 is 1616 plus 8x. So here, substituting 8x from this equation, so here 8x against cancelled, and we have to leave 1616, while on the other side of the equation, we have 1296 and 72 minus 8, 72x. 72x minus 8x equals to 64x. So total we found out that 1296 plus 64x equals to 1616. So here subtracting 1296 from this equation, so here we have only with 64x, while on the other side of the equation we have 1616 minus 1296 equals to 320. So in total, if you found out that 64x equals to 320, here we divide this equation by 64. So we found out that 64x over 64 is x, and 320 over 64 is 5. So in total we found out that 5 equals x equals to 5 units in itself. 8 equals to x equals to 5 units in itself. Our task is to find out the length of AB. AB in total equals to AD plus DB. AB equals to AD plus DB. So AB in total equals to AD, that is x, plus dB, that is 4. So total AB equals to x plus 4. But x is 5. Therefore AB equals to 5 plus 4, that is 9. So total, actually found out that the length of this side AB of this side ABC equals to 9 units in step. So finish to repeat on the first solution of the first question. The next step, I repeat on the solution of the second question. In the second question, we had two tasks. The first task is to find out the length of this square ABCD, and the second task is to find out the length of this tangent QP. So in the drawing, we have a semicircle and a quarter circle that are located inside square ABCD. This is tangent QP, this is tangent to both the semicircle and the quarter circle at this point. Again, our task is to find out the area of this square ABCD, and we have also to find out the length of tangent QP. So first of all, we define the relevant point to this question with letters. We define the center of this circle, this point is point O. We define this point as point L. We define this point as point Z. We define the roof of the shoulder segment B as X. Likewise, we define the roof of last segment BZ as Y. DQ is the radius of this quarter circle, equals to 45 units in its length. This is what we need, equals to 45 units in its length. Okay. We know that the radius of this quarter circle is 36. So it's 36 according to what is one in the question. The radius of this semicircle is 17. Therefore, OL is also the radius of the semicircle, that is 17. What is the area of this square ABCD? So our first task was to find out the area of square ABCD. Actually, we know that the area of any square equals to the roof of one side squared. So it is AB square. So the area of square ABCD equals to AB square. AB in total is 17 plus 17, that is 34 plus x. Therefore, AB square is 34 plus x square. And again, AB square equals to 34 plus x square. So in total, according to the first method of calculation, we actually found out that the area of square ABCD equals to 34 plus x square. We choose it's one side of this square ABCD is BD, therefore the area of square ABCD equals to BD square according to the second method of calculation. And the area of square ABCD according to the second method of calculation equals to BD square. BD equals to y plus 36. So BD equals to y plus 36, therefore BD square equals to y plus 36 square. So we have two different equations for the area of square ABCD. Therefore, calculate equation 3 that said that the area of square ABCD according to the first method of calculation must be equal to the area of this same square ABCD according to the second method of calculation. The area of square ABCD according to the first method of calculation equals to 34 plus x squared, it must be equal to the area of the same square ABCD according to the second method of calculation, is equal to y plus 36 squared. So in total, according to equation 3, we found out that 34 plus x squared equals to y plus 36 squared. Here to hold out this equation. So if the square cancels the root, we left only with 34 plus x. Likewise, if the square cancels the root, we left only with y plus 36. Here subtract 34 from this equation, so here 34 will get cancelled. And and you left only with x in the side of the equation, and on the other side of the equation, 36 minus 34 is 2, so in total inside of the equation we left only with y plus 2. So in total, according to equation 3, I should found out that x equals to y plus 2. So here we can implement rule 10 in our drawing. We can implement rule 10. According to rule 10, if two circles touch each other externally, then the side line that connects the circles together passes through their touching points. In the drawing, those two circles touch each other externally at point P. The center of this circle is here at point O. The center of this circle is here at point M. The side line that connects the circles together is of course the side line OM. According to this rule 10, the side line OM must pass through their touching point, that is point P. Again, the side line OM must pass through point P, that is their touching point. OPM is one side line. Again, OPM is one side line according to this rule 10. Therefore, OM in total must be equal to OP plus PM. Okay, actually, for 10 in our drawing, because we have an external between the semicircle and the concentric circle at point K. The center of this semicircle is at point O. The center of this concentric circle is at point D. The side line that connects the circles together is of course the side line OD. According to rule 10, the side line OD must pass from point K, that is their touching point. So we join points on D together by straight line, and indeed the straight line on D indeed passes from point K. This is the touching point exactly according to OK. So OD in total must be equal to OK plus KD because ODK is one straight line. Okay? OD in total equals to OK plus KD. Is equals to OK plus KD. So OD in total equals to OK, that is 17, plus KD, that is 36. So in total, OD equals to 17 plus 36, that is 53. And OD equals to 53, it's in Israel. So, in the next step, we implemented the Badasum on this real and real OBD. First of all, this is the right angle because it is one of the angles of square BCD. So the opposite OD is 53. So we implemented the Badasum on this right angle OBD. According to the Badasum, in the right angle, this was the opposite equals to the sum of the source of the perpendiculars. That is to say, OD square equals to OB square plus BD square. Again. OD square equals to BD square plus OB square. OD is 53, therefore OD square is 53 squared is 2,809, and it's equal to OB square. OB is 17 plus x, therefore OB square is 17 plus x square plus BD square. BD in total equals to y plus 36, therefore BD square is y plus 46 square. So in total, we should all know that the triangle BD according to the Badasum, OD square equals to BD square plus CB square. BD square plus CB square. And OD square equals to BD square plus OB square. This is actually BD square plus OB square. OD is 53, therefore OD square is 53 squared, that is 2,809, and is equals to BD square. BD is y plus 46, therefore BD square is y plus 46 square, plus DB OB square. OB is x plus 17, therefore OB square is x plus 17 square. So in total, we actually found out that 2,809 equals to 36 plus y square plus x plus 17x. Again, 2,809 equals to 32 plus y square plus x plus 17 square. But we only found out that x equals to y plus 2. So we can substitute x by y plus 2. So in total, we found out that 2,809 equals to 36 plus y square. Here we have x is y plus 2, so in total x, that is y plus 2 plus 17 equals to 19 plus y squared. So in total we found out that 2,809 equals to 36 plus y squared plus y plus 19 squared. So 2,809 equals to 36 plus y squared. 36 plus y squared equals to 36 squared plus y squared plus 2 times 36 times y is 72y. So total, if you know that 2,809 equals to y squared, 1296 plus 72y plus y squared plus, so we open the brackets of this expression and found out that 2,089 equals to y squared plus 72y plus again 1296. We found out the value of 36 plus y squared. 36 plus y squared equals to 36 squared, that is 1296, plus y squared plus 2 times 36 times y, that is 72y. Likewise, open the brackets of this expression, and we actually found out that y plus 19 squared equals to y squared, plus 19 squared, that is 361, plus 2 times y times 19, that is 38y. So in this the equation we have only 2,809 equals to y squared plus y squared is 2y squared. Likewise, 361 plus 1296 equals to 1657. And finally, 72y plus 72y plus 36y equals to 110y. So in total we found out that 809 equals to 2y squared plus 1657 plus 110y. So here we subtract 209 from this equation. So here we have to with nothing, that is to say 0, and on the other side of the equation we have 2y squared plus 1657 and 1657 minus 2809 equals to minus 1152. So total we found out that here we have 2y squared plus 110y and 1657 minus 2089 equals to minus 1152. So total we found out that 0 equals to 2y squared plus 110y minus 1152. So our first task is to find out the area of this square ABCD. So we actually found out that here we can implement all 10 in our domain. So I'm going to click on all 10. Because we have an equivalence between the semisecond and the quarter-second at point K. So according to rule 10, if two circles touch each other externally, then the side line that connects the circles together passes for their touching point. And at the moment we have those two circles that touch each other externally at point P. The center of this again is at point O. The center of this again is at point M. The side line that connects the circles together is of course the side line OM. According to this rule 10, the side line OM must pass for point P, that is the touching point. Again, the side line OM must pass for the touching point, that is point P. So in total, therefore OPM must be one side line. If OPM is one side line, it means that OM in total must be equal to OP plus PM. So we can actually implement rule 10 in our drawing, where we have an external between the semisecond and the quarter-second at point K. That is to say, they touch each other externally at point K. So we can implement rule 10. The center of the second is at point O. The center of the second is at point D. And the side line that connects the circles together is of course the side line OD. And according to rule 10, the side line OD must pass for the touching point, that is point K, or OKD is one side line. So actually join points O and D together by side line, and according to rule 10, the side line OD must pass for point K, that is the touching point, and indeed the side line OD passes for point K, that is the touching point. So in total, OD must be equal to OK plus KD. OD equals to OK plus KD. So OD equals to OK. OK is the radius of this semisecond, that is 17, plus KD. KD is the radius of this quarter-second, that is 36. So in total, OD must be equal to 17 plus 36, that is 53. OD equals to 53 units in its length. So in the next step, implement the Pythagoras theorem on this right diagonal OBD. According to the Pythagoras theorem, in any right triangle, the square of the opponents equals to the sum of the sides of the perpendicular. So this is to say, OD square equals to OD square equals to OB square plus BD square. So again, according to the Pythagoras theorem, OD square, that is the square of the opponents, equals to BD square plus OB square. OD is 53, therefore OD square is 53 squared, that is 2809, and it equals to OB square. OB is 17 plus x, therefore OB square is 17 plus x squared plus BD square. BD is y plus 36, therefore BD square is y plus 36 squared. So in total, we shall know that OD square equals to BD square plus OB square, that is to say 2809 equals to 36 plus y square plus x plus 17 square. We already found out that x equals to y plus 2, so we can substitute x into this equation by y plus 2. Therefore, x plus 17 is y plus 2 plus 17. Y plus 2 plus 17 is y plus 19. In total, this expression equals to y plus 19 squared. And so in total, we found out that 209 equals to 36 plus y squared plus y plus 19 squared. So here, 209 equals to 36 plus y squared. Open the brackets of this expression. 36 plus y squared equals to 36 squared, that is 1296 plus y squared, plus 2 times 36 times y, that is 72y, plus y plus 19 squared. Y plus 19 squared equals to y squared, plus 19 squared, that is 361, plus 2 times y times 19, that is 38y. So, as you found out that 2809 equals to y squared plus y squared is 2y squared, and 1296 plus 361 equals to 1657, and finally 38y plus 72y equals to 110y. So in total, if you want to 2809 equals to 2y squared plus 1657 plus 110y. So here we subtracted 2809 from this equation. So in this side of the equation we left nothing, that is to 0. While on the other side of the equation we have 2y squared plus 110y, and 1657 plus 2809 equals to 1752. So in total, if you found out that 0 equals to 2y squared plus 110y, 1752. Then again, 2y squared plus 110y plus 1152 equals to 0. Here we divided this equation by 2, and finally found out that 2y squared over 2 is y squared, and 110y over 2 is 55y, and 1152 over 2 is 576 equals to 0 over 2 is 0. So in total, if you found out that y squared plus 55y plus 576 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that you are looking for. And we find out the value of the value of x, according to the following formula: x equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0, the variable that we are looking for is y, so x equals to y. The coefficient a equals to 1, the coefficient b equals to 55, and finally the coefficient c equals to minus 576. So we have all the data that is needed in order to find out the value of the values of y, because y might have also two solutions. The only thing that you have to do is to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of y. So we did it, we found out that x is y, because y is the variable that we're looking for, equals to minus b. B is 55, therefore minus b is minus 55, plus minus 4 to b squared. B is 55, therefore b squared is 50, b is 53, therefore b is 55, therefore b squared is 55 squared. That actually equals to 3025 minus 4 times a times c. So it is minus 4 times a, this is 1, so minus 4 times 1 is minus 4 times c. C is minus 576, so in total minus 4 times ac equals to minus 4 times minus 576. This is actually 2304 divided by 2a. A is also 2, is 2 times 1, that is 2. So in total, we found out that y equals to minus 55 plus minus the square root of 3025 plus 2304 divided by 2. Okay, again. So inside the root we have 3025 plus 2404 plus 3025 in total is equal to the square root of 5329. So total actually found out that y equals to 155 plus minus square root of 5329 over 2. So y equals to 155 plus minus the square root of 5329 is 73 divided by 2. So total we actually found out that y equals to 155 plus minus 73 over 2. So here we have two solutions that are possible for y, but we take into account only the positive solution for y. Because of the fact that y is the ref of bz, therefore it's a ref, it must be a positive number. The positive solution for y is as follows: y equals to 155 plus 73 over 2. 155 plus 73 is 18, 18 over 2 is 9. So we found out that y equals to 9 units in its ref. But we already found out that x equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So in total we found out that x equals to 11 and y equals to 9. Our first task is to find out the area of this square ABCD. The area of square ABCD equals to AB square. The area of square ABCD equals to AB square. AB in total is 17 plus 17 is 34 plus x. AB is 34 plus x, therefore AB square is 34 plus x square. So in total we found out that AB square equals to 34 plus x square. So AB 34 plus x is 34 plus 11. 34 plus x is 34 plus 11 plus x equals to 11. So the area of square ABCD equals to 34 plus 11 square. 34 plus 11 is 45. So this 45 square. 45 square is 2025 square units in its size. So we found out that the area of square ABCD equals to 2025 square units in its size. We finished with the first test for this question. The second test is to find out the ref of standard QP. What is the ref of standard QP? We have to find out the ref of standard QP. In order to find out the ref of standard PQ or QP, we define this angle BDO as alpha. So the angle OBD, this angle equals to 90 degrees, this angle equals to alpha, therefore this part this angle must equal to 90 degrees minus alpha. 1 plus 90 degrees minus alpha plus alpha is 90 degrees, 90 degrees plus 90 degrees is equal to 180 degrees, it is the sum of the angles in the triangle. Therefore this part this angle must equal to 90 degrees minus alpha. We have tangent QP that is tangent to this contact area at point K. The radius dk that is called of this contact area, the radius dk is 1 to point K, that is the point of tendency of tangent QP with this contact area. And whenever your radius is 1 to the point of tendency, then tangent QP will be perpendicular to the radius KD. If QP is perpendicular to KD, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So in the small right triangle QKD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. This is the sum of the angles in that angle. Therefore this first angle must equal to 90 degrees minus alpha. In the next step we need the construction, that is to say, from point P, we do perpendicular on BD. Again, from point P, we do perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we created the smooth quadrilateral PTDC. Inside the smooth quadrilateral PTDC, we have 1, 2 threads. Why? Because of the fact that those two angles are both right angles, because there are two angles inside square ABCD. Therefore, must be right angles. So inside the small quadrilateral PTDC, we have 1, 2 angles. The sum of angles is 270 degrees, so 270 degrees plus the side of this fourth angle, so that must be equal to 360 degrees. According to the law, that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth angle must be equal to 90 degrees inside. So inside the small quadrilateral PTDK, we have 4 angles. Therefore, we can write quadrilateral PTDK as a rectangle. We know that AB equals to 34 plus x, x is 11, so AB in total equals to 34 plus 11, that is 45. Therefore, BD also equals to 45, and CD also equals to 45, because of the fact that the size of any square are equal to each other in their lives. So actually found out that inside the quadrangle PTDC we have quadrants, and from the quadrangle PTDC is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle PTDC, side CD must be equal to the opposite side PT, but CD is 45, therefore the opposite side PT must be also equal to 45 units in its length. So inside the rectangle QPT, this angle equals to alpha, this angle equals to 90 degrees, and therefore this this angle must be equal to 90 degrees. But also according to the sum that says that the sum of the angles in any triangle is equal to 180 degrees. So in the next step we prove that the green triangle OBD can go into this triangle QPT according to angle side angle rule. So what the green triangle OBD can go into this triangle QPT. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, BD equals to PT equals to 45. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. Therefore, we should find out that the green triangle BD can go into this triangle QPT according to angle side angle rule. And again, we should find out that the green triangle OBD is OBD. The green OBD can go into this triangle QPT according to angle side angle rule. And from the fact that the green triangle OBD can go into this triangle QPT, we derive their corresponding sides must also equal to each other in the left. But what is angle side angle rule? We actually found out that those two angles and the side is included between those two angles in this green triangle BOD corresponding equal to those two angles and the side is included between those two angles in this triangle QPT. Therefore, those two triangles can go into each other according to angle side angle rule. Repeat again. We actually found out that those two angles and the side is included between those two angles in this green triangle corresponding equal to those two angles and the side is included between those two angles in this triangle QPT. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we have that the corresponding sides must also equal to each other in their lengths. That is to say, we have that OD equals to QP. OD equals to QP according to the rule, the corresponding sides of congruent triangles are equal to each other. The green triangle OBD can go into triangle OPQ. Therefore, the corresponding sides must be also equal to each other in the length. OD is the corresponding side of PQ. Why? Because OD is the opponent of the green triangle, therefore it must be equal to the opponent of the other triangle. QP is the opponent of the right triangle QPT. So, because of the fact that those two right triangles are equal to each can go into each other, their hypotenuses must be equal to each other in their lengths. So the hypotenuse OD of the right triangle must be equal to the hypotenuse QP or the right triangle TQP. Because they are the two corresponding sides. But we only found out that OD equals to 53. So we can write that OD equals to 53, and from this equation 53 equals to OD equals to QP, we have that QP must be also equal to 53 units in its length. So in total we should have found out that the hypotenuse QP equals to 53 units in its length, and the area of this square BCD is equal to 2025 square units in its size. Okay, thank you very much.